Let's do some friction practice. Carol pushes a 10-kilogram wood box across a wood floor at a steady speed of 2.0 meters per second. How much force does Carol exert on the box? So let's assume that the box slides to the right, and that means that the friction force opposes the motion by pointing to the left. So let's draw a free body diagram. We have the force from Carol. We have our friction force, and that is kinetic friction because the box is moving. We have our weight, and we have our normal force. So the problem tells us that the box is moving at a constant speed of 2 meters per second. So it is in what's called dynamic equilibrium. Therefore, the net force is equal to 0. Remember, these are vectors. So that means all of the vectors in the x direction are equal, and all of the vectors in the y direction are equal. So we can actually determine how much force Carol exerts on the box. Remember, that's what we're trying to do in this problem. We're trying to find the force of Carol by setting up an equation. So we know that the force that Carol exerts is equal to this kinetic friction force, and the kinetic friction force is equal to the coefficient of kinetic friction, mu, times the normal force. Sometimes you'll see this normal force written as F sub n, sometimes you'll see it as a small n, and sometimes you'll see it as a big N. So make sure you write that down. All three of these terms mean the same thing. In order to find this normal force, though, we have to solve for the forces in the y direction, So first what we need to do is set our force of gravity equal to our normal force. And we know the force of gravity on this box because we are given the mass and we are assuming that we're here on Earth, so we have the acceleration due to gravity. So remember, F sub g equals mass times gravity, which equals 10 kilograms times negative 9.8 meters per second squared. This is a negative here. So that is equal to negative 98 newtons, and therefore our normal force is 98 newtons. We can plug that 98 newtons into this equation here for the normal force, and now all we need is the coefficient of kinetic friction. And when problems don't just give you the coefficient of kinetic friction, you have to assume that it's something that you need to look up in a table. And so I looked it up in a table and found that when wood is on wood, our coefficient of kinetic friction, so it would be kind of given to us, we could put it over here, mu sub k is equal to 0.2. So in that case, my kinetic friction force, F sub k, would be equal to 0.2 times 98 newtons. And that means that our final answer for this force for Carol is equal to the F sub k, which is equal to 20 newtons. About 20 newtons. So this is the force that Carol needs to apply to the box to keep it moving at a steady speed, a constant steady speed. And I do want you to notice one thing about this problem, and that is that we never used this 2.0 meters per second. And the reason we didn't ever use it is because the speed, this 2.0 meters per second at which the Carol pushes the box, it doesn't enter into the answer at all, into our determination of the answer, because our model of kinetic friction doesn't depend on the speed of sliding the object. So the speed at which the object is pushed does not factor into this problem.